Oh, okay. Yeah. So I guess the first thing we would do if we want to talk about like how to land on planets is what type of planet? Like what's the situation? Is it hostile? Is it known to us but we just haven't landed on it, or is it like a new planet?
Let's for right now, let's keep it to unexplored planets.
So like a new planet like we've never encountered. Do we know the type of planet? Like is it a gas giant, cold? What is it called? Like a cold, like a Neptune, Uranus?
Well, in a sense, let's say a spaceship goes to a gas giant. It's surveying the spaceship, and the crew is surveying the planet with their eyeballs and saying that's a gas giant. It doesn't have a surface, therefore I can't land on it. So in a sense, that is a step in the pre-landing procedure.
So I guess like you go to a star system and then figure out what planets there are, figure out what type of planets they are, and then from there, first of all, just gas giants. And what is this word called? Like for the Neptune and Uranus, they're not. Oh, ice giants.
Ice giants, yeah.
Yeah. So you rule out gas giants, you rule out ice giants. At least for now, we don't have the tech to like live on those, so don't even bother. I guess maybe you do some like material analysis for later on, see if you can extract stuff. But in terms of landing, you just find like the rock planets. What is this called? Rock planets.
It's just rocky planets.
You find the rocky planets.
Find the rocky planets, yeah.
Okay. So then you decide like, go ahead.
But there could be rocky moons.
Okay, yeah. So inventory the moons too, and the ice moons. Those could be useful for human life. Then I guess you decide you want to land on planet, 7 or whatever it is. What do you do next?
So I guess the original thing you're just describing is a survey of the solar system to figure out what has surfaces so you can land on it. Once you get to the planet, now you need to do a more refined search or survey of that particular planet. Atmospheric composition, especially atmospheric composition, weather, surface, is it liquid, is it mud, is it dry, all that stuff. That would be step number 2.
So I guess so yeah, there's a balance between speed, like you want to get down there, you don't want to survey for years, but we need to balance this off with some actually very legitimate safety concerns. So I guess can we run through like what are the generic safety concerns? So I guess one is like physical. No. Let's do physical last. So chemical. So does it have like toxic things to humans? Do we have atmosphere that we can breathe?
Well, this is all relative to the safety equipment, PPE suits that we have available on the spacecraft. So if it's pretty regular that we encounter bad environments, like the atmosphere is too high in pressure, it's too hot, the chemical composition is bad, but we have the spacesuits to immediately handle it. We just survey the planet, figure out what spacesuit we have to wear, and wear the appropriate one. So if we're talking, can we land without a spacesuit? I don't think you would ever do that on an unexplored planet.
Oh, so actually, we need to walk it back even further. So you light speed jump, whatever, however you're going to get there, and then you survey the system, figure out what type of planets are there, which ones are interesting to even go investigate, and then you choose the 7th one, you go there, and then you orbit it for some time, and you're like scanning the planet, like even before we're even considering it. So like you got to figure out what is there. But then like, do you go down with planet? I would drop a probe in. I would drop like a robotic lander to like, actually go measure the stuff. And I guess you could use spectral analysis, but at some point just send something in there.
I think what my mind is saying is that you do those few orbits just to take into account that you're going to do many, probably a week, just to make sure there's no weird weather things that are rapidly changing that might catch you off guard.
Good point. Yeah, like say a planet has high electrical storms, like you wouldn't think it, but then now you land your craft on there and it's getting shocked by lightning. No good.
So you do this survey of globally on the planet, and then over the course of a while, so you have good chemical composition, good surface composition, all that figured out. Then you hone into maybe 1 or 2 landing spots that you may find interesting, you can land at. Then I think you send a probe down there and characterize that particular location to make sure it's safe. You don't necessarily need to go into that detail for the whole surface, but for those 1 or 2, 3 locations for landing, you maybe send down 3 probes. Assuming you've got space flight, you're doing faster than light travel to these things, you probably have the tech to do throwaway probes.
Yeah, set and forget it, throw it down, see what happens.
So what would these probes be looking for, do you think?
Yeah, so I guess they need to figure out the very first things is safety. So as we said, it was chemical. So is stuff toxic to humans or our PPE? Is the pressure? So it's I mean, even if you have like a planet of argon, which does nothing to you, but it has so much pressure that it crushes you, that's still lethal. And then on the other side, if it's too thin of an atmosphere, you could never take your helmet off. Like this, we talked about electrical. So it could be that like a planet has very, very high probability of lightning strikes. Well, you need to think about that. And other weather effects. So it could have like you could have a torrential storm and have flooding, and then all your equipment's washed away. So you have to like think about how is the land shaped to where the water flows. Earthquakes, I guess. How ooh, that would be a hard one to do. How do you figure out if a planet is prone to earthquakes?
Well, is the Earth prone to earthquakes?
I mean, yes, but not really. I mean, the fact so in California, we're worried about a big earthquake, but at the same time, we've populated the area, so it's prone to earthquakes, but also so slowly that we don't really do anything about it.
So the real question about the earthquakes is the land shifting under your feet so regularly and with such frequency that it actually becomes a danger if you stay down there for a short amount of time. So that means like landslides, rock slides, boulders, flooding.
That's a good point, like because at this point of exploration, when you've just found a new planet, you're not planning to settle for a long time. I mean, you're there for a week or something to assess the situation. So dangers like earthquakes far down the road.
Yeah, so even volcanoes, you could even land on a volcano. I mean, we build cities around volcanoes right now. So, but on Earth, volcanoes erupt every couple hundred years if it's active.
It's inconsistent. It's
right.
particular to that volcano.
Right, that's right. So some of them are thousands of years, some of them are hundreds of years, some of them are like pretty constant, but not like explosive, different things like that. But you could just build cities around it and not worry about it. Whereas if you went to Io, the moon of Jupiter, those volcanoes are just spewing all the time. It wouldn't be safe to land on anywhere near a volcano because it could erupt at any time.
Are they called ice canos?
So I think on Io, they're like actually molten stuff.
Oh, really?
Because it's the gravitational tidal heating on Io is so intense that it actually melts. It's not, I don't know if it's rock. It's some kind of sulfur or something. I don't know what the composition of the
some
lava
type of
is.
slurry something. Oh, curious.
Yeah. Whereas in other moons in the solar system, it's more like cryovolcanism.